So we will be building a simple CRUD application where the application will be built over the Spring Boot framework, and it will be integrated with MongoDB, and we'll be dockerizing the complete app and test it on local. So the key learnings as part of this project would be, you'll be able to create a Spring Boot app from scratch using spring.io. You'll integrate that with Gradle, which is a build tool that is used to manage the dependency, build the project, and it gives a utility to start to start the Spring Boot app. We'll create a couple of endpoints which will be integrating with MongoDB to store the data and to fetch the data. Yes, we'll be also integrating the app to MongoDB, as I said. And also we'll be dockerizing the app, which means we'll be starting the MongoDB container on local using Docker Compose, which will be basically downloading the image of MongoDB and starting its container so that it could be connected to the Spring Boot app. And finally, we'll start the MongoDB container as well as item service Spring Boot app and test the endpoints what we have built using the curl commands. Let us try to create the item service. Let's head into spring.io. Spring.io gives a tool called Spring Initializer where you can start and build the bare bones of your service. So here I will choose, you have an option to choose either Gradle or Maven as a build tool. I'll choose Gradle, and then I'll choose language is Java, and I will use the latest version of Spring Boot 3.5.6. And this project metadata is something you'll give the project package name where your code will actually sit. So let's tag my service name. I can change it to item service. My packaging would be jar, and I will be using Java version 17. Now I would need a list of dependencies which I need to build my project. So one is Spring JPA, Spring Web. Other than that, since I'm using MongoDB as a persistence layer, so I would need MongoDB JPA. Other dependency I would need is Lombok. Lombok is something which will give you getter setters automatically. So this is just to avoid some boilerplate code. So here we have added a list of dependencies. Spring Web for creating endpoints, it will give you a list of annotations and support. Spring Data MongoDB is a library to connect your server with a MongoDB database, and Lombok is a dependency to remove some of your boilerplate code, and it gives getter setter automatically. So now I will hit generate. This will basically download a zip file. I have to unzip it, and so I have now imported the project into IntelliJ. I have the IntelliJ community version, which is absolutely free. To import the project into IntelliJ, you can go to File, Open, go to the location where you have downloaded the dependency, where you have downloaded the zip file. For example, I don't downloaded the zip file into this folder. If you just click on item service, it will basically configure your project into IntelliJ. So when we created the project from Spring Initializer, what it gives you a set of structure to your project where your source file will live in, where your test will live in, how your dependencies would be downloaded, and all this stuff. So since we use Gradle as a tool to manage dependency and build, so you would see build.gradle.kts file. And since we use these dependencies, it will add those dependencies in here. Let's try to build the project using Gradle command. Okay, so build is successful. Basically, the Gradle has downloaded the set of dependencies which we have given. You can also see we have a folder structure with the name specified, which we give into the artifact name while creating the project. So you have Spring Boot application created here. You have test folder created with the bare bones. Now let's also try to run the Spring Boot application. So you will see the Spring Boot application started on 8080, but there is a set of errors which are expected because what we have did is we have included MongoData JPA as a dependency in our project, right? If you see, we have Spring Data MongoDB JPA as a dependency. Now what auto configuration feature of Spring Boot does it tries to connect to the MongoDB. But since we doesn't have the MongoDB instance running on my local, so it basically gives you the error while starting the Spring Boot application. So next, let's try to fix the Spring Boot startup issue. The issue here was the Spring Boot app was expecting a MongoDB instance on the local, but since we haven't started any MongoDB instance on the local yet, so this was expected. So now what we have to do is we have to start a MongoDB instance on the local where the Spring Boot application can connect when we start the Spring Boot application. So simplest way to do it is via Docker container, where we start the Docker container on local by downloading the image and running the Docker Compose. So Docker Compose is something which we can use to run multiple Docker containers via a single command. So let's try to do that. Create a file called Docker Compose, and I will start the MongoDB service. We would also need the volume where actually MongoDB store the data currently. Cool. We would also need a bunch of application properties so that Spring Boot application know on which port it actually has to connect to MongoDB. So we'll go to application.properties and we'll add a bunch of properties. So I've added a bunch of properties here in the application.properties. One is server.port, so this will specify where the Spring Boot application will start. So I'll start the Spring Boot app on 8081. The default is 8080, I think. So second is I'll give a URL where to find the MongoDB container. So if you go in here, you'll find this. So now let's try to do. Let's try to first up the Docker container of MongoDB. So the command I'll use is docker compose up. So docker compose up will basically start all the Docker container which is specified in docker compose.yml file. Since I've just specified a single container as of now, so it will start the MongoDB container. So you can also go to the Docker desktop, which is an app which you can download on your Mac, and see if the Docker container is up. So if you see the Docker container is up just 14 seconds ago, and it is using the mongo.latest image which we have specified in our Docker compose file. The next step is, because we have did some application changes, let's rebuild the Spring Boot app and we'll try to start it again. It's built, let's try to run the Spring Boot app again. So expectation here now is that it should start without any errors now. Cool. The Spring Boot app is now started on port 8081, which we specified in here, and it is also connected to the MongoDB. Cool. Let's try to build the item application from the scratch now. So we'll have to build a couple of layers which the Spring Boot have in any REST web service. So the first layer would be the controller layer. So what we do is first we'll define the package structure so that we have clarity, and then we'll actually define the implementation inside it. So first we would be having this controller layer where the request first hits, then we have a repository layer. Repository layer is basically which talks to the database, and service layer would be something which sits between the controller layer and repository layer. So your request comes to controller layer, it delegates it to service layer, and service layer will talk to repository layer, and repository layer will in turn talk to the database to fetch the data. We need a couple of more packages to define the DTO structure. So DTO is package where you define your request response structure. Apart from it, one other package you would need is model. So model is basically where you define your database schema, POJOs. So this is nothing but a representation of your database tables in the form of server-side code. So let's start with building the DTO layer. DTO is nothing but the request and response. So you would need a couple of classes, item request and item response. Item request will have, we would basically need these four attributes of an item from the client, like item name, category, SKU code, and price. And response would also look the same. And it would have an additional field which would be ID. So ID would be auto-generated from the database. So the DTO layer is done. Let's build the model layer. So we need a class name item. I think I created a wrong class. Let me build it. So we would need a few annotations. One is document. So this basically specify that this is a MongoDB document, and we can also specify the name of. So this would basically give the name of the MongoDB collection. This is the data. So these two will basically specify that this is an POJO class for the table in the database, and this is specify this is a MongoDB document which is of type redirect. And these are few Lombok annotation. We'll try to understand in the later phase where they're exactly used. So you have a bunch of attributes, ID, so define the model class. Now let's go and build the repository class because that's the innermost layer. This would be interface. So it is item repository. I think this extends Mongo repository, and you have, I think, item string. Basically, what we can do is, I think this is again not correct. So basically, what we can do is, as we have included a dependency, if you go and see, we have included a dependency of Spring Boot Starter Data MongoDB. So Mongo repository will give you all the CRUD operation methods like save, get all out of the box. So if your application just needs those methods, you can just extend the existing Mongo repository and define the type in it. So for example, our collection name is item. We'll define this is a Mongo repository of type collection type item. So this will give you a pre-built all those CRUD methods automatically. So you don't have to build those into the application layer. Cool. The repository layer is done. Let's come to the service layer. So let's name it item service. Because this is a service, let's add the annotation. So this would depend on item repository. we have to rename it. So we need a bunch of methods. One is to create an item, and second is to get all items. So should be public void create item, and second would be public list of item response, and let's say get all items, and we would need the request body in the input, item request. So if you see, the role of service layer is basically to convert the client request into a form of objects which the repository layer understands. So that's what we are trying to do here. So this is where the builder class comes in. As we define the @builder on top of items, so it automatically gives the builder pattern with the help of lombok. Cool. With the help of repository. Cool. Support this. Let's implement the get all. So give me okay, so this is how the get all items is implemented. We find all the documents from the MongoDB, and then we stream it and convert it into a item response which the client is expecting. So if you see in the service layer, we just act an intermediary between the controller layer and the repository layer. Okay, since now the service layer and the repository layer is done, let's go and build the controller layer. Let's say this is a class called item controller. Nothing. So request controller annotation will specify that this is a controller where the request would be received. This defines the path, the endpoint path, the base path. So controller layer will basically depend on the service layer. So we would need a couple of methods here. Create item, yes, we need that, and I think we will need item request. Similarly, we will need list item response. This will basically be done, and service dot create item request. Cool. Now we also have to specify that what kind of method this is, the HTTP method. So this is a post method, and we also have to specify the response code. And this is a get method. Cool. I think now we have built all the layers. So this is a controller layer which would be depending on the service layer. So to create an item, it will call the service layer create item. This is the service layer which will be depending on the repository layer. It will create an object of type item, which repository layer understand, and it will call the item repository.save. So item repository is extending a Mongo repository which have all the items, which have all the methods to save and get the documents of type item. Cool. Let's try to build this now. Cool. Now we'll start the we have completed the development of the application. Let's try to test the application now. So first thing is we have to up the Docker container. We have MongoDB container defined in the Docker compose file. So let's try to first up that. Cool. So we have started the MongoDB container now. Let's check in the container. So MongoDB is running. Let's now start the application. Okay, so the application started on the port 8081. Let's now try to test the couple of endpoints which we have created in the item controller. One is the post endpoint at the path API/item, and one is the get item to get all the items. So I already have the call request for post. So let's try to use that. So basically what we're doing is we are trying to send a post request to an endpoint API/item, which is on localhost 8081. Since this is a post request, so we have to also send the request body. So if you see the request body, it is the same which we have defined in the item request. Item name, category, SKU code, and price. Let's try to hit that. Before that, let's do one thing. Let's try to hit the item endpoint, the get endpoint. So expectation it should currently have 0 items. Okay, it works fine. So we basically see that none of the items are returned because we don't have any items yet. Let's now hit the post endpoint. Okay, now we have hit the post endpoint. Now let's hit the get endpoint again. Okay, so get endpoint has written an item, but all the item name, category, SKU code, and price are null, which basically mean that there is some bug in the code because of which the request which we are sending is not propagating correctly. Even though the CRUD operation is working fine, but the request items is sent. It's been interpreted as null. Okay, let's try to check the controller layer. Okay, let's try to check the model. Looks fine. Repository layer also looks fine. To check item controller. Okay, I think we missed one annotation, request body. So this is basically responsible for converting the request which we have sent from the curl to the object. So because it was not there, so all the attributes of the item request were null. That is why it was being saved as null. Okay, what we have to do now is to rebuild our Spring Boot application and deploy it. To build. And let's try to run it again. Okay, so application is again started on 8081. Let's try to hit the post endpoint now. And now let's try to hit the get endpoint. Okay, so we fixed the issue. So if you see, this was the previous item which has all the entries at null. Now we have the item which we just saved with the help of post request. Let's try to create one more item. Let me, instead of item name as MacBook Pro, let me try to make it something else. Let me try to make it Samsung. And let's also change the SKU code. Sanji. Let's try to hit this endpoint, a post requester. Okay, so this is successful. Now let's try to hit the get endpoint again. So you'll see there is one more item created with the item name Samsung.